My name is Marino Wijay, and this is...
Um, I'm Kat Morgan, DevRel at Pulumi. Really happy to be here. Really fun to introduce ourselves halfway through.
Yes, I know. I tend to do that. Like, we just jump right into it, and then we'll go right into introductions later on. But I want to start off with the mindset as well, right? There are different personas that exist in cloud native, in open source, in enterprise. And the one particular engineer that exists out there is a platform engineer that actually tends to overlap with the network engineer. So I like to bring back the network engineers back into the conversation, primarily because they're the ones that are going to be responsible for every aspect of your network. When something goes wrong, who do you call? Not the platform teams. You'll call the network engineers because the network is down, right?
Ghostbusters.
Right? Ghostbusters. Okay, sure. But you'll call the network engineers because you can't hit a website, you can't hit an app or something along those lines. Today, you'll probably log a ticket and we'll go to some platform engineering team and they'll find a way to troubleshoot it. Now, if you actually think about documenting your entire network, it actually is not a fun task. It's not easily achievable, especially if something you decided to deploy out of nowhere and then you started adding on to it over time. Now, the right network stack is one where you start off with documentation, kind of like how I've laid off in the right, and then you build upon it. Because guess what? You could take that, store that in version control, and then deploy in a very repeatable fashion across any infrastructure. Now, I also want to bring about the OSI model because it's always going to be relevant. Even in 2024, I still use the OSI model. I don't care if you use the OSI model, but I will, and you will start using it after today. Primarily because it easily maps to a data plane, which is Kubernetes. It provides a stack or a layer for network transport, which is Cilium. And now interchangeably, like literally Cilium can climb up that stack and even handle things like your layer 7 application layer, things like HTTP communication, those requests that happen between your services, something that Istio could handle or any other service mesh out there, even Cilium can do it too. And that's the cool thing about how you look at a network technology and how it evolves. But it's not about Cilium, it's not about Istio, it's not about Kubernetes, it's about using any development language that you're familiar with to spin these up for your just-in-time needs. So I also want to bring about another note here because we're going to go micro and then we're going to zoom out a little bit. So if I wanted to provide networking for my containers, what I need to do is I need to construct something called a networking namespace. Now, a networking namespace is just an isolation mechanism inside of your Linux operating system. It allows you to isolate processes into their own little network environment or a virtual network, which can be attached to a virtual switch. And then that little process can have outbound access, provided you've got the right NAT pieces in place. But the reality is to create this repeatable process means automation, meaning if I wanted to spin up a process and then turn it down and then associate a TCP/IP networking stack to it, I can automate that. It actually has been automated today in Kubernetes using something called the container networking interface. The CNI does this because when you think about containers, they're short-lived in the world of cloud native, meaning they come and go. And we need an onboarding process and an offboarding process for when these containers come and go. This is what a CNI is doing for us. Now, okay, let's zoom out a bit. Now we've got a data center that we own and we have to manage. While we're having to configure those networks for our containers and pods and everything in between, we also have to think about the physical layer and how that physical layer interacts with our virtual layers, our container layers, etc. So there's a lot more networking that goes on. And then we zoom out even more because guess what? We're not just doing this in one data center. We're doing this across like many cloud environments, many data centers, edge environments, etc. And so we want to codify this all. But there's like BGP in my YAML. If I say I want to configure BGP, okay, hold on, let me back up a bit. I showed you a whole bunch of like network devices here. This is a global scale network that we're looking at here. Something that is like, that spans the world, meaning I might have a data center and a set of networks that exist in Toronto, and then another set that is replicated in Singapore, and another set that's replicated in London, etc., right? And the one key aspect is repeatability. So I want to be able to repeat this over and over and over again. And I can only do this if I store this all in code. So BGP, for example, is a routing protocol that I use to be able to facilitate this communication. But if BGP not only lives in my network devices, my physical network devices, but also lives in cloud native, well, I have to codify it somehow. So this is where BGP can live in YAML. And I can take this and then throw this up into source control, and then I can let the Pulumi magic or the dev magic take place. But anyways, I have an opinionated approach of what the right network stack looks like. It could be any kind of public or private cloud that you have out there. If it's something you decide to build your own, whether you're provisioning instances and then programming the rest, or you're taking advantage of something called Pixie. Have you all heard of the Magic Packet before? All right, the Magic Packet is still alive and well today, and that's how we bootstrap hardware. In fact, if you're familiar with this company called Equinix, Packet, right? They actually bootstrap a lot of their bare metal using something called Tinkerbell, which uses the Magic Packet to just basically bootstrap an operating system on top of the hardware, and then everything else is configured, whatever it might be. So there's a lot of different ways you can cut up your stack and make it look, right? It's just entirely up to you and your needs. And the reality is your needs are going to vary across whether you're doing cloud, whether you're doing something at the edge, whether you're doing something bare metal, and your workload style is going to vary as well. Now, having said that, how do we make this all look nice in code?
Okay, so how do we make it all look nice in code? Because ultimately, what we want to do once we accomplish something and achieve success is make that success reliable, repeatable, and shareable. So in the world of ops, where we actually take these amazing ideas and these great technology tools, I like to refer to each individual technology as like a Lego block, and you get to build an entire tower with all of these Lego blocks. And you can sit there and stack things one at a time, following the instruction manual, and end up with a Lego set. But what if my son really likes to destroy Lego sets? How do we get back to that successful Lego build, right? And that's where we actually go back to the drawing board, the strategy for ops, and we say, where have we come from? Where are we now? And is this actually, going to lead to our success as an organization, as an individual, whatever it is that actually gets us to our goals? So looking at the journey to infrastructure as code, we come from a background that was really heavy with ClickOps. So if you're familiar, if you've heard of things like VMware or Proxmox or Hyper-V, it's really common to jump into the land of virtual machines by clicking around in a web UI or a console. And that's a really neat way to get tangible experience with the technology that you're using. But what if you want to automate it and make that success that you've achieved reproducible to reduce the risks of human error, or to make it possible for other people to achieve that same success you found? And that's where we reached out and invented all kinds of automation. You might be familiar with, whether it's Ansible, Terraform, any of those other automation tools. And now we have a way to achieve the outcome. A lot of these tools, whether it's bash scripting or PHP, not PHP, right? We end up reaching that successful finish line. But are we in the place yet where we're optimizing our automation methods to really give ourselves business intelligence, observability into how we actually achieve that success, or control over what happens if something goes wrong along the way? Because a lot of automation that follows an imperative journey, apparently I touched it, a lot of automation that follows an imperative journey can derail, causing failure at best, or unintended consequences at worst, right? And no one wants to clean up from that. And that's when we actually stepped back and said, okay, we can do this declaratively so that we know exactly, precisely what we want when we move to that next. Okay, so with declarative automation, what we're actually talking about is infrastructure as code, where we describe all of the things that we want, and we get that outcome. So there are lots of different tools. I'm from Palumi. We're going to talk about Pulumi today. What what is it that actually defines a good orchestration tool? And I like to use this kind of analogy about like a fast food restaurant. We've all driven through, you might be a health nut, maybe not. I've driven through fast food restaurants and wanted to order chicken nuggets or a burger or whatever, right? Well, when I get to the drive-through menu, I don't want to yell out, I want a bun, and I want you to toast it, and then I want you to put cheese on it. Like, all of this very procedural, imperative process of ordering a burger would be completely unreasonable, which is why they create a menu. And then you point at it and you say, I want a number 2, right? And they produce that end result and give it back to you in the window, right? And that's kind of what orchestration is. You're saying, of the resources in this cloud, for example, Kubernetes, firewall, things like that, I want these ones made just the way I like it, hold the pickles. And then when you apply that, you do Pulumi up or Terraform apply or any of those other commands that actually initiate the process, what it ends up doing is making a call to the API of the cloud resources that you want to say, hey, create these things. And then you just get the hamburger, right? So what I like about Palumi is that you actually get to use general purpose programming languages for your IaC. Now, I am not a native developer. I come from support ranks, doing enterprise support on individual systems or on OpenStack even. Don't ask me how I feel about Python. And throughout all these journeys, it's always been refreshing when I could achieve success in something, fixing a problem, or generating a new exercise that helps people understand and prevent problems in the first place. Doing that myself was neat. Being able to share that with other people, that's when I got really excited. So I really, so I get pretty passionate about infrastructure as code when it comes to writing the code and then sharing that around. There's another piece of the reusability story that is actually really fun, though, because if you find yourself performing a ClickOps operation, say creating a virtual machine, more than once, that's a good indicator that maybe you should automate it. And the same thing happens with IaC. If you end up writing something in code more than once, maybe you should turn that into a reusable component that you can just call import into all of your consuming repositories. With GitOps, you can version control it and roll it out at a reasonable pace instead of just committing everywhere that you're using to expect that rollout instantly everywhere could break a lot of things. So that version control becomes important when you're doing something like a reusable component, but you can import all of these things as libraries in your existing IaC and then use general purpose programming features to do things like look up the latest version of a Helm chart if you're pre-prod and you just want to test everything with the latest versions, right? So today's talk, how far are we in? Is about policy as code, right? And we're talking about writing a policy with IaC that applies to your network to secure your application, both from external bad actors as well as internal consequences of just having everything wide open. I bet Marino could get into that someday. That would be a fun talk. Anyway, so with policy as code, we're thinking about it in terms of bite-sized pieces that we can reuse. And we're looking at, in our demo, how we actually, how we're actually going to write that IaC. So earlier today, we're going to test this policy on Civo Kubernetes in demo prod. This is what we're actually working in right now is a GitHub Codespaces. So the details will be on the next slide for how to go and find this GitHub repo and play with it yourself. And the repo, the main branch right now, is all built on kind Kubernetes. Earlier in the speakers lounge, we were having a blast flipping out kind Kubernetes for Civo Kubernetes, which I was impressed with. Is actually really, really easy. Once you realize that the venue Wi-Fi does not let you access the Kube API. So we're going to jump into the IaC. We have a Kubernetes cluster already deployed. So are people able to read that on the screens? Okay, cool. All right. So at the top, we are importing 3 packages from the Pulumi registry. We have a ton of packages, so explore to your heart's content. And we're also pulling in a config, because I can sit down and do Pulumi config set on different keys and then consume that in my IaC to control how we're actually going to make the IaC behave. So part of the Kubernetes story was building the firewall, commented out the 6443 rule because the default rule allows all the ports. So that was actually causing some weird stuff. It'd be fun to get into someday. We have our Kubernetes defined here. So this is our Kubernetes cluster. And I don't know how many of you have written IaC or manually created kubeadm clusters or used something like K3s. By far, this is the easiest Kubernetes cluster I have ever built. So give it a try. And then what we're actually doing in this IaC is we're grabbing our kubeconfig and we're going to use it to actually do things like deploy our app. So we have an app here. Do you want to tell them what the app is and what the policy we're going to play with is going to cover?
So we actually have, I don't know. Oh, yeah, I should probably speak into the mic. Okay. So we actually will be deploying the Cilium CNI. Has it been deployed yet or no?
Yeah, Cilium is deployed. We have an app.
Okay.
And we have everything except for the policy in place.
Okay. So we have this app called the Star Wars app. And the Star Wars app actually has 3 resources. One is the Death Star, one is the TIE Fighter, and one is the X-Wing. So the intent of what our network policy is supposed to do is prevent the X-Wing from landing into the Death Star. And we should be able to see that by running some curl requests against these pods and see how they communicate. So you'll see the pods. I think they're already deployed. We just have to deploy the policy. One thing about network policy is that there's Kubernetes network policy, which is actually pretty limited in functionality. Like you could block services and the communication of services, and you can't get very granular in that sense, but you can scope it to, services within a given namespace. But when you want to get very granular, this is where something like the Cilium network policy resource comes in. There's a lot of additional granularity where you can actually scope your policy to something cluster-wide. It could be at the node level. It could be across multiple namespaces. It could be namespace scoped. It could be just label scoped across different namespaces if you wanted to. And there's a lot of different ways and flexible approaches that you can cut that up. But what's also really cool is that Cilium network policy also does layer 7, which is where some of that WAF functionality comes in. We're not there yet, but what we're attempting to do is just implement that policy so that we can prevent the X-Wing from landing in the Death Star. So you want to go ahead and deploy? Let's go.
Yep. All right, so real quick, since we already have everything deployed except for the policy itself, let's do a little before and after magic. I'm going to fast forward over here to step 3. Can't double click because, it's a preview. There we go. All right, let's do this. Go away. Copy, paste, why are you failing me? There we go. All right, so we're gonna run a quick curl. You can see Death Star is getting a request from the TIE Fighter, and we're getting a response back from our web server. We're gonna actually see a non-compliant command, and this is an X-Wing, so obviously probably should not be landing on the Death Star right now. But we got in anyway. So this is where we're at before we actually apply the policy. So let's take a look at our policy in the TypeScript really fast.
Oh, you added it in there? Oh, I didn't realize that. Okay.
Yeah, when I said it was good,
okay,
I
nice.
meant
Good,
the last minute miracle was happening. All right. So in here, what you'll see is we're actually pulling a Boolean off of the config key policy strict. Because maybe we're pre-pod and we don't want to work on these policies yet. But this is something that we're actually going to control here in just a moment and rerun Pulumi up to pull in. So you'll see in here the Kubernetes custom resource it's written as a network Cilium policy. And then we're actually going to use pod labels in here.
Empire, org equals empire.
Yes. Yeah. Okay, we're going to match labels to understand if the traffic is allowed or not, right? So let's go ahead and do... We're going to set our config, and what did I call that? I don't have this practiced yet. We're going to set it to true to override that default of false, and then we're going to do Pulumi up on here. Now this is going to be where we actually test this in demo prod. No. What is it doing? What is it doing? Have I doomed us to failure because I was dead set on using a new Kubernetes distro?
No comment.
Okay, that's okay. So if failure is captured on video for posterity, we're going to fix that in the repo so you can try it again later.
So the other option is we could just manually apply the network policy and that should work fine.
That's cool if we have the network policy handy. But I don't.
It's not in the repo?
Not the YAML.
Oh, dang it. Okay.
Remember, we wrote it in Palumi.
Yeah. How do I convert that back to a YAML now?
Okay, so bear with the timing of failure. This is why he said that I made all this happen, because now he still looks good.
I've myself in the situation.
Yes.
No.
Well done. I'm learning this tip.
We're in this together. Okay.
Okay. All right. So if we go back to this curl command, the demo gods will smile on future repo revisions. Ultimately, what you would see here is...
I will say we do have time, so if we want to fix this on the fly...
If we want to fix this on the fly...
Let's fix this on the fly.
Do we want to... Do we really... Okay.
Let's fix this on the fly. Come on.
All right.
This is like totally not scripted whatsoever. We never... I don't know if we'll actually fix it, but we'll try. But it's an attempt.
So I'm actually wondering if you're right and the CRDs just aren't in there on this version of Kubernetes.
What version of Kubernetes are we using?
We are on... Let's see, custom resources.
Oh, this is the thing I said earlier.
Yeah.
Okay.
That's how
it's just like a random thing I was thinking about when I was okay.
Yeah, you totally put up the warning sign too. You were like, it might not work, and I was like, sure, it'll work. Okay, so let me actually switch to namespaces where we're using all. I cannot do that, so let's do kube system because that should be where our CRs are. No views. Namespace. Sweet. Now I should have CRs. Where's Cilium? Okay. Forget GUIs. Do we just not have Cilium installed? Because it said it was installing Cilium.
Just maybe do a get pods -a.
No, that's okay. All right.
we're gonna install Cilium now, I guess.
Okay, so we can install Cilium. We're not going to do it right now. That sounds like too much surgery on the cluster, but like we're supposed to have Cilium.
Yeah, you do have the Cilium CLI though, right?
Yeah, I got that. Oh, okay, that's right. We can do Cilium install.
Cilium install. There you go.
Okay, you have the CLI commands.
All right, let's see. Cilium install. Done.
Sweet. Yeah, the code space is latency is killing me right now.
Status, and we are looking almost good, I think. Oh no, am I gonna run into that same?
Yeah, see, that's why I wanted to use the vendor Cilium setup. Yeah. We can just drop them, the curl command that is supposed to return nada for the TIE fighter.
Yeah.
And then continue the talk. Let's do that.
That's fine.
Okay. So
we tried.
Yeah. All right. So that command, curl command that returns ship has landed. ultimately, when the policy is applied, once the CRD that we're expecting exists, at that point, we're going to get no response from the container because the traffic no longer matches the policy labels that we're expecting on the pods themselves.
So another way to consider and look at this, right? If you actually look at all the pods in the namespace, so I'll just do a clear, and if I do a kubectl, I'll get pods dash a, or it's actually in the default namespace dash show labels. Handy command to have if you're studying for your CKA. Hint hint. You'll notice that the TIE Fighter has the org equals empire. And as well, where's the Death Star? There it is, as well as the Death Star, right? Org equals empire. But the X-Wing does not have that label. So the policy, its intention is, because that label is not there, traffic will be denied. And that's intended. That's how it's supposed to work. We should probably go back and investigate what's going on with the Kubernetes version and that CRD. But I suspected as much. But anyways, let's continue.
No, it's good. So let's wrap up real fast. Ultimately, if you want to try this for yourself, the main branch is solid and not thrown together last minute.
Actually, we still do have time. We could kick off the code space again if you want.
If people want to stick around afterwards,
we literally have still
really
8 more minutes. Yeah. Do you have
with this Wi-Fi?
Let's go.
Okay.
I mean, this is the last.
I'm on my phone Wi-Fi though. This is going to be magical. Oh, this is code spaces though. Okay. So we're gonna do. Yes. Yeah. All right. Apparently we have someone racing us now. So let's do make kind. We're gonna build our kind cluster. Just all this dead air.
So the
real fun.
The difference in the actual setup here is that this is kind, the other one is just Civo. So we'll just have to investigate what's going on the Civo side. And I think, so per my original observations, one of the things is when you actually start to use newer versions of Kubernetes, it hasn't, we haven't always checked if it aligns with the versions of Cilium, especially if we use a built-in version of Cilium, because it might be using an older version, which means any sort of policy that we may apply, even though the CR might exist, maybe the policy element or the actual field doesn't exist. And that's probably why it doesn't get applied to. So
cool.
Almost there?
Yeah, the cluster is just about ready. What we're going to end up doing next is just a couple of rudimentary new project commands. We're logging into Pulumi Cloud, installing the NPM packages that we need. Then we're creating a stack, which is what we call specific deployments of our IaC. You can have multiple stacks with different configs from the same IaC. So if you're doing dev staging prod, you're just revising your configs depending on the environment that you have. And then we're going to do the Pulumi up to actually deploy Cilium with the right CRDs and all of that stuff.
We actually have 11 minutes.
We have 11 minutes?
Yeah.
Oh, right.
Yeah,
so we're gonna fall on our face and cross the finish line victorious.
Exactly. There we go.
Okay. Cool. Actually, this is a good time for Q&A.
Yeah, exactly.
So let's run some Q&A. If people have questions, be bold, be loud.
So I will. Yeah, go ahead.
How's the Palumi code talking to these different systems? Is there a local registry? Is it talking to an online system? Where am I registering credentials?
All right, so it's a really good question. The question was, how is Palumi actually interfacing with these APIs? And the second part of the question is, where are credentials? In this very rudimentary setup, what we're doing is we're using the Palumi packages from the registry that get downloaded locally, building a graph of all of the API calls required and the order that they need to be called in, to go out to the internet and call the APIs directly ourselves. In the case of Civo, you actually pass a token to my config, which is why it's good to know where are the secrets being kept. At the moment, it's salted and in the YAML here, just because we were building this rapidly. Palumi offers IaC, which is a cloud-hosted secrets and configuration storage. Or you can consume this directly from, say, AWS Secrets Manager or any of the other big secrets vaults out there. Totally be curious what you think about secrets management and how Pulumi does it later on. We'll have to follow up on that. Any other Q&A to run real fast?
Okay, good.
Sweet.
Oh, it's doing that thing.
Yeah. All right, we grabbed our dependencies. We are going to init and name our stack and do. All right. So again, this is going to kind Kubernetes locally in the code spaces.
That looks a lot nicer. Yeah.
All right, and what you can actually see is it's identifying, hey, I need to create certain things as child dependencies before I proceed on to applying other things, which can happen a lot as you're going through. Pulumi has ways to actually say, hey, do this, then do this. This other thing has to wait until the first thing is ready and stuff like that. So you can do concurrency and waits and stuff pretty easily. And so
the one thing I really appreciate though is that when you look at that index.ts file where literally all the configuration lives, for someone that isn't a developer, me for example, I read that and it's very easy to decipher and discern what's going on, because a lot of that also looks like Helm configuration in a lot of ways. So for folks that aren't familiar with a programming language and maybe want to pick up one, TypeScript might be a great place to learn, because to me it's pretty readable and easy to like understand what's going on here.
All right, we're back on track.
Yep.
And all of the resources are deployed the way they're supposed to be. So
so the network policy is also deployed?
network policy is there.
Cool.
All right, so we've got our labels, and we're going to go straight to the command that wasn't working before. And then we can still fit in some navigating around. All right, so what you're seeing is it's trying to reach out to that pod that doesn't exist, and the pod's not going to return traffic.
Meaning the X-Wing could not land on the Death Star. Unfortunately.
That's really a shame. The Empire should not still be in power.
Thank you. Actually, thank you, Kat.
Teamwork.
Yes.
All right.
Okay, to wrap up, right? Kat, do you want to wrap up, actually?
This was rehearsed. Okay. Then we changed the plan. That's not how the order you're supposed to go in, but it was a lot of fun. Thank you for bearing with us. Definitely kick the tires if you want to see enhancements on this very specific set of IaC. Drop an issue on the repo. I try to watch my repos and like engage when people say, hey, I like this policy, but I haven't figured out how to do this thing. We'll team up and solve it together, right? Cilium made it all possible. Marino, you taught me how to use Cilium because I was afraid of it until we actually started putting this together. So thank you.
You're welcome.
It's all yours.
Yes, and I'll close off by saying if you actually go dig into this repo and then you go back a bit, you know, up a level to Kat's profile, you'll start to find some other repos there like Cargo, right? And I bring up Cargo because there's some stuff going on the bare metal side, on the, you know, running bare metal Kubernetes, being able to do like bare metal provisioning, etc. And it's nice to be able to see that side of this entire, you know, IaC stack and story. So go check that out. Go check out Cilium as well. Go check out Istio if you really want to understand how deep networking can get. But at the same time, follow us on Twitter and see some of the bullshit we talk about all the time. Take care, everyone. Thank you for your time. And we will see you at the booth crawl.